Hey there, algebra friends. Welcome to section P3. Lots of good news here. First of all, it's a much shorter section than P2 and P1, and it's just a nice break from all the really tough stuff we've been doing lately. So this should hopefully be a breath of fresh air for you. We're going to talk about our friends' polynomials, and then different operations we can do, adding, subtracting, but focusing a little bit on special products here. How can we multiply polynomials? All right, first of all, the word polynomial, what is that? The word poly, the part of it means many, and nomial, you think it'd be names, but actually refers to terms. So a polynomial is an expression that has many terms. Now, it could have one or two, or it could have 100, but just polynomial is sort of a general term for all these types of algebraic expressions with many terms. For example, we have 2x plus 5 is a polynomial with two terms. We have 3x to the fourth minus 7x squared plus 2x plus 4 is a four-term polynomial. We can actually have polynomials with not just x, but y's, and any variable, a's and b's, whatever letter of the alphabet you like. This is a three-term polynomial. Okay, to really give it a good definition. Now, don't let this expression here scare you, but it's basically just saying that every polynomial that we're going to see in terms of the variable x is made up of, generally, a number in the front. And these are all real numbers. And the subscripts there, a subscript n or n minus 1, or on the end all the way on a subscript 1, just show that they are different numbers on different terms as we refer to them. But they're all real numbers, as you see up here. And they just go down a sub 1, n, a sub n minus 1, and so on, a sub n minus 2, all the way down to a sub 0. These are all just numbers. And what we're going to say is the x terms are here. X to the n, x to the n minus 1. So these n's and n minus 1s are all exponents or powers. This last one here is x to the 1. And believe it or not, there is an x here. You just can't see it. It's invisible. And you're probably like, Mr. Brown, what's wrong with you? No, it really is there. If we go all the way down in descending order, if we start with, say, x to the n, x to the n minus 1, x to the 5, x to the 4, x to the 3, x to the 2, x to the 1 right here, this last one would actually be an x to the 0. So that's where we would end. But you remember from the last section, anything raised to the 0 power is just 1, which is why you don't see it. And that's why you have basically 1 times the coefficient in front of that. Okay, so you can see every polynomial is made up of a combination of these a's, which are coefficients, if you remember. So all coefficients in front of the x variable. And the x's are just the variables. But don't let the subscripts or superscripts freak you out. It's just an official definition of a polynomial. Now, we need to talk about the highest power that you see, the highest exponent in a polynomial. When you see it written in special order, the highest power, whether it's x to the 5th or x to the 100th, is going to be called the degree. This is an important word. We're going to bring back this a lot. So put a star next to it, burn that into your mental hard drive. But the highest power, the highest exponent, right up here in the front of that x variable is called the degree. And we're going to refer to it a lot because it has a lot of neat properties that affect the polynomial and the graph as well. The a subscript n, that coefficient that's in front, well, that whole term here, this guy, because the n is the highest power, he's in the front. He's the leader. So this is the whole leading term here in this big red bubble. So wouldn't it make sense that this a sub n here is the leading coefficient of the leading term? So the leading coefficient is the number that's all the way in the front of the highest x power. The one all the way in the back, the n, the caboose, the one that doesn't have an x attached to it, just a plain number, he's just called a constant. So we often call him a constant term, a sub 0, the one on the end without the x. Okay, so we've listed sort of all the bare bones, the skeleton of a polynomial. Now we can refer to them by names depending on how many terms they have. So for example, if I have a polynomial with only one term, like for example, just 3x, where 3 is your coefficient, and you have x to the 1 power, and there's only one term, but he is still the highest power, so this is a degree of 1. All right, he's only one term, right? So the name for him is mono, means one. He's a monomial. So it's like you're taking polynomial and you're just taking the mono part to attach to it and make it a monomial. How about two terms? If you had two terms, for example here, 5x squared minus 3. 5 and 3 are coefficients. X to the 2. So the 2 exponent is the degree. And the 3 here would be the constant term at the end. Actually, a negative 3 would be the constant term at the end. Hey, two terms. Bi means often two, bicycle. So a binomial has two terms. And finally, if we have three terms, think of a tricycle, trinomial, just like you see over here on the right-hand side. Negative x squared plus 9x minus 1. The leading term is minus x squared. The highest power is 2, so that's your degree. It's kind of weird to see it, but the leading coefficient is negative 1. See the negative in the front? And the constant term at the end is also a negative 1. You take the sign with it. Okay, we can go further and have 4 terms, 5 terms, but we generally don't have names attached to those, so these three are the most popular names that you will see. Monomial, binomial, and trinomial. It's really helpful to play with polynomials when they're written in descending exponent or descending powers. And when we have that, it's called standard form. If you have a polynomial such as x to the 4th plus x cubed plus x to the squared plus x to the 1 plus 1. That's in standard form because if you look at the exponents or the powers, they are in descending order. There's 1 there. But if I mix it around and I say x to the 4th plus x to the 5th plus x to the 2, you can see that's not in descending order. That 5 is in the way. And so we need to rewrite it, maybe put the 5, x to the 5th in the front, and that would be in standard form. You want to practice that? Let's try it. Let me give you a couple polynomials here, folks. 3 of them. Check and see, is it in standard form? Are all the exponents in descending powers? After you do that, can you tell me the highest power, meaning the degree? Let's see, in the first one, folks. Let's see, I have x to the 2, x to the 7. Oh, darn. Well, right away, I know that's not in descending order. Let's find, what is the highest power there? I think it's x to the 7. So I'm going to take that entire term and put that in the front, including the negative, because the negative 5 is now the leading coefficient. How about negative x to the 7th, negative 5x to the 7th? What's the next highest power? How about the squared? So that's a plus 4 in the front, so I'll say plus 4x squared is the next term. 2 left. I would say this 3x is the next highest power, so plus 3x. And finally, we end with minus 2, our constant term at the end. That, my friends, is in standard form. Nice. Now that we have that, look how pretty it is, because can you see the highest power now? The highest exponent is 7, so the degree of that polynomial is 7. The degree is not x to the 7, it is just the 7, just the power. All right, how about the second one? Let's see, this is 4, which again, when you see 4, you're thinking 4x to the 0. So the power there is 0. Ooh, and the next one is 2, so that's definitely not in descending order, right, friends? So let's rewrite it. How about put the negative 9 with the term. That's in the front. And then the plus 4 is the constant. All right, that's in descending order. We have x to the 2 and then x to the 0. So that's descending. Even though we skipped x to the 1, that's okay. It doesn't have to insert 1 in there, as long as the exponents are in descending order. Now that we're in standard form, do you see the highest power? Yep, so the degree of that one is 2. And that's also called a binomial because it's 2 terms. How about just 8? What a strange one to deal with. Again, it's just a number, so you can think of it as 8x to the 0. There's no order here because it's only one term, so the standard form would still just be 8. But look at it, now that I wrote 8x to the 0, can you see that the highest power is the 0? So this is a degree of 0. It's not a degree of 8. Careful. 8 is the coefficient. So the hardest thing is once you see this, can you see the degree of that is 0? Because that's from x to the 0. Kind of tricky, right? So there you go. There's a little intro to polynomials, and now we get to play with them. Okay, here's what you can do. You can do anything. You can add, subtract, multiply, divide, and we're just going to take it one step at a time. I love the adding and subtracting ones. Here, we're going to take a trinomial and a 4-term polynomial. We're going to add them together. So by addition. Just like you've done in Algebra 1, the way to do it is to add like terms or subtract like terms. And by like terms, I mean terms that have the same x to the same exponent. Okay, we can't add an x to the 3 and an x to the 2 because they're different powers. But I could maybe add an x to the third over there and another x to the third over there. So let's figure that out. Well, first of all, we're adding. So because we're adding, we don't have to really worry about distributing the plus. It's not going to change what's inside this parentheses. So if it's okay with you folks, I'm going to rewrite it without the parentheses. Here's what I have. I have 5x cubed. Notice I took out the parentheses. Minus 7x squared minus 3. And now I'm going to take out the next parentheses. I have plus x cubed plus 2x squared minus x plus 8. Now, some people like to write it horizontally like that, and then just sort of scan your eyes across and look for the like terms. The highest power here is 3. So I'm going to gather up my 5x cubed and my 1x cubed and add those. Planning ahead, how about squares? I have negative 7x squared and a plus 2x squared. What else? I have just a negative x to the 1 power here. And finally, my constants I have here in red. All right, so let's add them together. If we take the purple, the 5x cubed and the 1x cubed, I have 6x cubes. How about the greens? I have 7x squared, that's negative, and a positive 2x squared. So minus 7 plus 2 is a minus 5x squared term. Let's see. In the orange, I had just the negative x, and he's all by myself. So there's nothing to do with him. He just stays there. Fine. Poor guy. And then the reds, the constant terms. I have a minus 3, a plus 8. That would be a plus 5. And that's your final answer. There you go. Notice that he is in standard form because our exponents go 3, 2, 1, 0. So it's in descending. The degree here, do you see? Degree is 3. It's not asking for it, but it's just good practice that the highest power is 3. Now, some people would like to do this in a more vertical fashion. Watch, I'm going to rewrite it down here just for a second. Feel free, if you like it this way, you can always do it this way too. After I release the parentheses, I have 5x cubed from the first polynomial, and so on and so forth. Now, if I'm going to add the next polynomial, watch how I'm going to add this. Ready? Plus x cubed plus 2x squared minus x plus 8. Notice how I did it that way. I did it vertically. And I can almost mentally draw this line here and just add down. You know why that's so cool? Because your x terms, the ones that are alike, are right on top of each other. So you can just add down. And you would get 5 plus 1, 6x cubed, minus 7 plus 2, just add down. Now this minus x didn't have anything above it, so imagine just adding a 0 on top. And then minus 3 plus 8. Okay, you get the same answer that we had up here. So it's really up to you folks. Would you rather do a vertical adding that we did over here, the second attempt, or would you just do horizontal, which is probably a little bit more traditional, but I like them both. And honestly, whatever gets you the right answer, you do that. All right, you want to try number 2 on your own, folks? Just be careful. It's subtraction, so you have to think about when you release the parentheses. All right, pause the video and check back with me and we'll see how we do. All right, friends, here we go. So I'm going to release the parentheses. I have 7x to the 4 minus 1x squared minus 4x plus 2. Now, when I release the next parentheses, make sure you distribute the negative. So I'm multiplying every term by negative 1, which basically just changes the sign, right? Plus 4x squared minus 3x. Okay, I like colors. They help me visually see all the like terms. So I have x to the 4ths here. I don't have any x cubes, okay, but I have x squares and x squares. I have just regular x's and regular x's, and I only have one lonely constant term over there. Let's see what we got, folks. I'm going to put my greens together. 7 minus 3. Okay, we got the purples would be the x squares, so I have minus 1 plus 4. The orange, minus 4, minus 3, And the last term is just a constant term all by himself. Did you try this the vertical way? If you did you get the same answer? Great job if you did. So there's adding and subtracting. Adding is pretty straightforward. Subtracting is also straightforward. Just be careful of the negative sign when you have to distribute that in, folks. Okay. Now, when you multiply them like you see down here, they are right next to each other. We write them just side by side. You don't see the multiplication symbol in there, but it's in there. Imagine the little dot for multiplication is there. But because they are side to side, we can assume they mean multiplication. Now to do this, the famous way that we use is called FOIL. And you see that right here. Let me erase my work so you can see better. Is the FOIL method. Have you heard this before? I love foiling. It just organizes your work so well. Here comes FOIL. What FOIL comes from? The F of FOIL means you do the first product. First meaning the 3x multiplies the 5x. These are the first terms in each parentheses. Okay, when I do that, I would get, I'll write over here on the right side, I would get 3 times 5, and x times x, you add your powers, and there you go. For the O means the outer product, meaning these two terms. You can multiply the 3x by the positive 7. Okay, now they're not like terms, but don't worry, we're not adding and subtracting, we're just multiplying them. So a positive 3x times a positive 7, we can multiply the 3 and the 7 and just include the x. The O is the inner product, meaning this inner term with the negative and this inner term. So inner meaning in the entire picture of all 4 little terms, these are the 2 that are sort of on the inside. Okay, I can multiply negative 2 times a 5x is a minus or negative 10x. And finally, the lasties. The lasties over here are just the 2 last terms on the ends, the minus 2 and the plus 7. Okay, you multiply that, you just get, minus 14. Now, a lot of times when you FOIL, you just have to be careful. You might have some terms that you can still simplify and add like terms together. So our final answer, friends, would be 15x squared plus 11x when I combine those 2 middle terms minus 14. All right, so when you have 2 terms like this, it's very easy to use what's called the FOIL method. It's great. Great, great. Do you want to try some? Okay. How about number 1? You're going to FOIL that, just traditional. Oh my gosh, did you see number 2? Look at that. That's crazy. Wow. Okay, this is going to be a super type of foiling. I want to see if you can try it on your own, but just be methodical. This is like super FOIL. So you can multiply every pair with every pair. Like every term gets to play with every other term. Think this. All these lines represent multiplying terms together. Wow, I see 9 lines. You're going to be multiplying and get 9 terms before you simplify. Holy cow. All right, good luck. I'm going to try the first one by myself. See if you can beat me to it. All right, number 1, let's FOIL. I see 2x and an x. That's 2x squared. Outers would be my 2x and a 5. That would be plus 10x. My inners would be the negative 4 and the x. That would be minus 4x. And the lasts would be the negative 4 and the 5, which would be minus 20. I do see some simplification in the inside terms, so 2x squared plus 10 minus 4x would be positive 6x minus 20. There's my trinomial of degree 2 with the leading coefficient of 2. How'd you do? All right, number 2. Are you ready? Here we go. Now I'm going to do all the purples in purple so you can see it. But this is how you have to FOIL. Every term gets to multiply a friend in the other parenthesis polynomial. So starting with the purples, I get x squared times x squared. Actually, let me just erase this, and I'll do it in order so you can see. X squared and x squared, that's x to the add powers, 2 plus 2. Whoa, 4th. Cool. X squared and a positive 2x is a positive 2x add your powers. How about x squared times a positive 2? Is 2x squared. Cool. Okay, now the purples are done. How about the red? So now I'm going to take the second term here and multiply it by all the terms in the right parenthesis. Negative 2x times an x squared is a negative 2x cubed. Keep going. Keep going. And finally, the 2 on the end here hasn't played yet, so let's bring him along. How about, we're running out of a little space. There you go. We've got a ton of things to simplify. The x to the fourth, I think, just is what it is. How about the x cubes? We got a 2x cubed minus 2x cubed. Those are gone. Poof, get out of here. There's no more x cubes. Ooh, that's interesting. Okay, how about x squares? We have a 2x squared. Over here, I have another 2x squared. That's 4 of them. Ooh, but I'm taking away 4 of them. Get out of here. Sweet. Now, what do we have? I have a minus 4x and a positive 4. Are you kidding me? Oh my gosh, and what are we left with? Dude, that is hot. How cool was that, folks? Everything just canceled except the first and last term. But you see, when you count them up, we got 9 terms altogether. Crazy. That's super foiling. Good job, folks. All right. Now, how about some shortcuts? These shortcuts, first of all, let me say, they are not absolutely necessary. If you want to memorize them, all they're going to do is make your life a little easier. If you don't memorize them, then, you just got to multiply by hand and it just takes a little bit longer. Have some patience. So these are just shortcuts. Do you have to memorize them? No. But if you do, they're pretty cool. All right, special products. These are special ones that have special results that we can memorize. For example, if I take two terms, u and v, and I multiply them like this, where there's a plus in between them and a minus. Okay, well, watch what happens. Before we even get to the punchline, let me actually just multiply them out by hand and watch what happens. You have a u times a u by foiling. If you do the outers, you have a u times a negative v. That's a negative uv. When you have the inners, that's a v times a u, or I'll just put in alphabetical order. And then the last two pieces are v times a negative v. Do you see what happens in the middle terms? Poof, poof. And look what you're left with. So when you have the sum and difference of same terms, u plus v, u minus v, and you want to FOIL that, the middle terms will always cancel. So when you actually FOIL them, the oi's go away, and all you really have is just fl. So when you multiply them out, all you got to worry about is just the first term and the last term. For example, let's do x minus 2 and x plus 2. Now, like I said, folks, if you want to just multiply this out by hand, you can. This is a shortcut, though. So just do the fl. The fl would be the first, which is x times x. The inner terms will cancel. The o and the I. Oi's gone. Lasts. How about negative 2 times positive 2? That's it. That's all you have to worry about. Easy to memorize? I think so. The other two things we can do is, what if we square a two-term polynomial, meaning a binomial? Either squaring it where there's a plus in the middle or a subtraction minus in the middle. If you do, there's a special formula. And the reason why this is kind of cool to memorize is that, if you just know the formula, you can just plug it in. You don't have to really think about literally foiling it out. Because u plus v, remember friends, this is really important for algebra, u plus v squared is not just u squared plus v squared. Okay, you can't do that. That's totally illegal in algebra. You can't distribute a power over addition, right? We can only do it with multiplication and division like you learned in P2. So if you want to memorize it, you memorize it with this way, with the inner term. Let's get to an example and we'll see. How about if I do x plus 7 squared? Okay, now you could, again, just do x plus 7 times x plus 7, Mr. Brown, and FOIL that. And that's absolutely fine. Fine. But the shortcut would say, let's take the u and the v here and multiply it out. Just use the formula. That would be u squared plus 2 times u, here is x, times v, here is 7, plus v squared. Okay, and then we can just simplify the inner terms here, friends. We have x squared, 2 times x times 7 is just the 14x, and 7 squared is 49. So we just shaved off a little bit of time from doing it this way. Really just a little bit, but isn't that what shortcuts are all about? So that's what that's for. Even better shortcut would be if we're cubing it. And by cubing it, that means we're going to be multiplying it many times, right? We'd be doing this, and then this, and then this. That takes a long time. But could you do it? Sure. Do you want a shortcut? Oh yeah. Check this out. Okay, so for example, let's just jump right to an example. If I want to do, how about x minus 4 quantity cubed? I should just do plus 4 to start. Okay, let's look at our u's and v's. This is my u, and this is my v. You don't really have to worry about the sign in the middle because that's taken care of over here in the formulas. We have a sign with a plus and one with a minus. So you don't have to really worry about, is the v a plus 4 or minus 4? Just make it whatever the actual number is itself. Okay, by our formula, look over here on the right side. I should have u cubed, okay, plus 3u squared times the v was the 4. Keep going. Plus 3u times the v squared. And then finally plus the v cubed. Okay? Now we just simplify. The first term is x to the third, which is just x cubed. The second term here is, let's see, we have a 4 and a 3. That's 12. And then x squared. And the next term is a little crazy. We have 4 squared, which is 16, times 3. Oh, 16 times 3, I think that's 48, right? With just the leftover x. And the last term is 4 cubed. 4 times 4 times 4 is 64. So again, we're just shaving off time. Could you have done this by hand and just fill it out? Absolutely. But if you know the shortcut, it's better. Beware though, folks. Make a little mark here, maybe with a star. If it is subtraction inside, notice what happens to the signs. You start positive, negative, positive, negative when you input it into the formula. Shall we play? Let's play before we go. We're not going to worry about this real life example down here. But why don't you pause the video and try 1, 2, and 3. Okay, number 1. I think what I'll do is I'm going to pause right here because we're about the end of the video, and I'll put the answers in the worked out process to these problems in the next video, friends. All right, so go ahead and try these 3 and then check my next video and I'll show you my answers. Good job so far.